These are just regular transformers. The gray things that look like trash cans here, they're just regular transformers. And what we're doing is we're actually backfeeding it through a transformer back there, and we're going to put 7,200 volts on this conductor up on the top. So the top conductor is what we would call primary. The lower conductor, the lower conductor that you see there, that's our neutral, and that's our path to ground, right? So what we're going to do is we're going to demonstrate something that Steve teaches our linemen to never do, and we're going to create an arc. So we're going to create an arc just so you guys can see it. First of all, we're going to show you the voltage for two things. One, you can see what voltage we're dealing with, and it's also a safety measure for us to make sure we've got everything right. So you'll see, and this thing's not exact because it's not actually going to ground, but it's about 7,200 volts on this thing. So this is the real deal. This is really 7,200 volts. It's not, you know, there's nothing rigged up to make it look like that. It really is 7,200 volts. And we'll show you here in just a minute that it really is 7,200 volts because we're going to draw an arc. And this is something we teach our linemen not to do. But we also, a lot of our guys have never actually seen an arc because if everything goes right, you don't see the arc. So it's just going to be a bright electrical arc here. So you see the electrical arc, that's the, you know, we're taking it to ground there. And this, I will tell you, this is a very controlled arc because, I don't know if you noticed or not, but Steve's standing over at the kill switch. This thing starts at 0 amps. We're out in the real world, out on our actual power lines. It would be a much bigger arc. It'd be much more powerful, be louder, brighter, and a lot less controlled. So, one of the other things we hope to teach, why should anybody, if a power line's down, like after a storm, you know, most of us couldn't ever imagine, you know, living in a world without electricity today. There's so many conveniences associated with electric power. You know, you go in, you flip a switch and the lights come on, you turn the computer on, you turn, you know, air conditioning, that sort of thing. But there are times when electricity could be hazardous, like after a vehicle accident, wires down, after a storm when a tree falls down and knocks our power lines down. And if, like I talked about, if it's not tag tested and grounded, never consider it dead or de-energized. Because a down power line could be down in here and somebody could reach up and touch it, and it's going to do what we're going to demonstrate here. You become the path to ground, which is what we're going to do. And we're using a hot dog. Anybody, I guess you guys noticed that we have a hot dog on the end of our same conductor that we just used. And that hot dog, we use that to demonstrate what would happen if a human being were to walk up and touch, because a hot dog is the closest thing we could find to demonstrate that. So, gentlemen. As you can see, I mean, it really brings it to light. But as you can see, I mean, it's the real deal, and you would never want to become that path to ground. The thing about electricity is, as long as everything's insulated and it's working the way it should work, you can't see it, you can't smell it, you can't hear it, unless it's tracking or something like that. And you'll see that again, we'll show you in a demonstration. But you never know it's de-energized until we come out and make it safe. So if you see a down power, I've seen them down on the ground, you know, down on top of a car, that sort of thing, and they'll still be energized. And you know, you would think, like I say, the biggest misconception is that it would be certainly because it's on the ground, it's de-energized, or because it's hanging low, surely something's blown. But if that thing doesn't have a path to ground, it's not going to blow the fuse. There's no reason for it to blow, because like I say, if it's down here, it's still going to be energized. Now our linemen, like I say, they go through a 56-month training program. Our linemen go through a 56-month training program, and some of the things they do, you'll notice that Ronnie's wearing some special clothes and some special rubber gloves and sleeves like we're passing around now. And Richard, you want to show them how we test our rubber gloves and sleeves? What we do is every day we test our rubber gloves and sleeves a couple of different ways. One way we visually test them, and then we do an air inspection, we do an air test on our gloves. So Richard's going to show you how we do that. There's an air test. All he's doing is rolling it up, so it's catching the air, and he's going to put air pressure on it. He'll hold the ears up, the fingers up to his ears, and he's listening. You'll hear a hissing sound if there's even a little pinhole in those gloves. Then we'll turn it inside out, and you probably noticed that our gloves are two different colors. The main reason is if there's a crack, if there's like a hairline crack, and we do a visual check, Richard's going to pull the fingers apart to kind of, what we do is we check for little cracks or anything like that in the rubber, and it makes it easier for us to see, particularly when it's the other way. So if you're looking on the black side, and that yellow will really shine through if you've got any type of hairline crack in there. So what we can do when we've got a good rubber glove and our linemen are standing on the pole, that pole is at ground potential. And we'll show you some other things here in a little while. That pole is actually at ground potential, especially depending on how wet it is. But our linemen, oftentimes you see them, if a pole's away from the street or somewhere where we can get a truck to it, then we still climb. You know, you guys have probably seen some of our linemen climbing poles. So they're actually standing at ground potential, and they're working on energized conductors, and their life depends on these rubber gloves being in good shape. So Steve's going to show you. We're just going to take a pin, stick a pinhole in the finger. And we actually use this demonstration for a couple things, especially for our young trainees, you know, to demonstrate to them why it's so important that they do a good job testing those rubber gloves and don't forget and don't take it for granted. We use this to demonstrate to them what could happen if they don't properly check their rubber gloves. So what we've got our same ground lead that we use with the hot dog. Got it in a rubber glove, and you saw Steve stick the pinhole in there. And it actually may take a minute to get that thing to arc over, but we'll see how well we do. If they get in there with that pinhole and get working on the conductor, this is what could happen. So it's also a good demonstration for folks in the public that when we come out and work on things again, our guys go through a 56-month intensive training program. Watch out, that may be a little hot. Go through a 56-month intensive training program to learn how to work on electricity. They've got special tools. You can see Ronnie, you know, we're all wearing rubber gloves and sleeves. We're all wearing FR clothes. Even though the stuff that we have on, really, it may not look like FR, but you know, it's Nomex. And this is actually not a lineman that had a bad day. We actually took a blowtorch to this one just to demonstrate for our trainees. Hopefully they never see this in real life, but we use this to demonstrate for our trainees why it's important that we wear FR clothing. You know, because as you guys know, what's the benefit of Nomex? You guys know that, right? It doesn't add to the ignition of the fire. You know, especially if you've got like nylon on or something like that, poof, you know, you see this electrical arc, it's going to go up on you quick and it's going to hurt you worse. It's going to, you know, stick to your skin. So this thing it quickly extinguishes the arc and doesn't ignite and catch on fire. So we actually borrowed this hose from you guys this morning. We sprayed this thing down with a little water just to make it a good demonstration. And you should see, you may have to look a little closely, but this thing will actually conduct electricity. Can you hear that, see it? So actually that's a good demonstration for our friends in the fire department. But that fire hose will, after being hosed down with a little water, will conduct electricity. And that also depends on how dirty it is and that sort of thing, how wet it is. All right, this time of year, you know, we have a lot of homeowners out doing work and contractors out doing work, and the other people we want to get the message out to is them, particularly you know, our homeowners and painters and that sort of thing. What happens is people get so focused on the tasks that they're getting ready to do, like painting the house or doing some landscaping, cleaning the gutters out, that sort of thing, they forget to look up. We're going to show you what happens. Now, what we've got there, of course, it's insulated with one of our rubber blankets. And that just keeps it from going to ground on our trailer. We've got a grounding plate there, and Ronnie's going to take that aluminum ladder and draw another arc off the primary there with that aluminum ladder. Now, y'all remember the hot dog, right? If you were carrying that ladder on your shoulder, you'd be going to ground. That path to ground would be your body, just like that hot dog. You know, in this case, we've got it on a really good ground. But what happens in the real world is your body becomes that path to ground just like a hot dog, and we never want that to happen to anybody. All right, you guys, after a storm, we just had a little downburst come through the area not too long ago. And you see, sometimes you'll see tree limbs up on the line, but it's not touching anything else, right? Can anybody tell me why it's not really a big problem for us if it's we need to know about it, but it's sitting there, it's energized, it's not buzzing, it's not arcing. Can anybody tell me why? It doesn't have a path to ground. That's exactly right. Now, a lot of our, if you look around, a lot of our primary conductors are out on cross arms, and that same branch could be long enough to be hanging on one of our outside conductors, no real path to ground, and it's hanging low enough where a homeowner or somebody else could reach up, grab that, think they could grab that limb and pull it off. Well, they would become the path to ground, just like we just showed there. So tree branches, particularly when they're wet, they will conduct electricity. All right, how about like a Mylar balloon? You guys seen Mylar balloons hanging up on our power lines, I'm sure. You know, everybody gets them for Valentine's and birthdays and that sort of thing. Father's Day is coming up, and that's great. But sometimes those Mylar balloons can be a problem for us. We got a quick demonstration here to show that the Mylar balloon will conduct electricity. You'll see this a lot. It's going to sound and look a lot like the fire hose. Can you see the light coming on now? There you go. All right, so we've got 7,200 volts flowing through that Mylar balloon. It's not a great conductor, but it is a conductor. So if you happen to see a Mylar balloon, give us a call and we'll get out and get that thing down. Do you guys pull meters, house meters? What we want you to do in that case is call us. We'll come out and pull the meter for you, because inside that meter base, the only thing insulating the prongs on the meter from that ground potential in that meter base is some little plastic blocks, what we call plastic blocks. There's little insulators in there. And if one of those plastic blocks is cracked, that thing could go to ground. Now we've got this one in a situation where it's shorted out. We've got a little fuse in there, and we're going to show you what could happen. This is just a demonstration of what could happen. Might make a little pop, and a little smoke. What type of turnout boots do you guys wear now? Leather ones? Well, we've got an old turnout boot. We got someone from a volunteer fire department to help us out with a turnout boot. And I think one of the other myths is that the turnout boot could be insulated. And it does have some insulating value to it. But like I say, our guys, you see Ronnie's got rubber gloves and sleeves that are tested every single day. We showed you how we do a visual test. We do an air check. Our rubber gloves are taken down to our center for testing rubber equipment. They're tested out to make sure they're right. And a lot of things could happen on your boots. And the way we've got this boot rigged up right here is it does have like a lag screw through the bottom. But if you were to step on a nail or something like that, or get a hole in your boot, that sort of thing, that can actually be make you be a path to ground as well. So if you were to walk up, say, to a car door after a vehicle accident with an energized conductor, and we're just going to show how the electricity will flow through the turnout gear. Have any of you guys ever had to respond to maybe a crane or some type of piece of equipment? We've got this demonstration for anybody like someone with a crane. The same demonstration holds true for a vehicle accident. If a vehicle gets in an accident and one of our energized primary conductors gets on top of the car, a lot of times the misconception could be, well, that wire's on top of a car. Certainly it's going to blow a fuse or some type of breaker or something. It can't be energized, right? So we're going to energize this wagon. You'll see the watch light come on again. All right, listen close. Anybody hear anything? Any arcing? Smell anything? See anything? We don't see any arcing. We don't smell anything. We don't hear anything. But we're going to show you that wagon is energized at full primary voltage right now. Now, it may not be registering the complete, but it is actually energized at full primary voltage. It does, there's paint on the cart, that sort of thing. But the reason we demonstrate that is you can't, if you go up on a vehicle accident and there's wire down on top of that car, you won't smell anything, you won't see anything, you won't hear anything necessarily, but it could be energized at full primary voltage. And as you walk up and touch that door handle, to try to help somebody. And the other thing is for any customer or somebody, some of our customers or homeowners, that sort of thing, out there that comes up on a vehicle accident, everybody wants to help that person in the car. The person in the car may be injured, knocked unconscious, that sort of thing. So we want to go and help them. But the best way we can help them is call the power company, call us here at Dominion, let us come out and make it safe, and that way we don't have two people to try to rescue. So, does this guy look familiar to you guys? We made this little dummy. Now you can see he's got a copper ground, he's got a copper lead on him, but it just demonstrates, we saw with the hot dog how the human body will conduct electricity. Now we have this grounded. This is just a demonstration to show, okay, we're going to energize this card again, and this is what happens if you walk up and you become the path to ground. So, it's kind of small scale, but that is what really happens. Anything going on this time of year, spring around the house, anybody doing any gardening, the wife got you doing planting bushes and trees and that sort of thing, flowers. Did you call Miss Utility before you started digging? All right, some have and some haven't. All right, the thing about underground, and the difference between overhead and underground conductors, we saw there's some hidden hazards with overhead conductors, after a storm, they could come down and they could be energized. Someone could walk up and touch them. But there's also hazards with underground. And the biggest hazard with underground, anybody tell me what that is? With underground utilities? Right, somebody digging in. That's exactly right. Thank you for that. But the big thing with underground utilities is once all the construction is complete and people move in and a couple years goes by and grass comes up and people, bushes and things like that, you can't tell where the underground facilities are. You can't tell where the power lines are. You can't tell where the water lines are, or sewer lines. You don't want to get it cut into a sewer line either, because that's a whole nother story. But so if you go to dig, we want you to call Miss Utility. For bonus points, can anybody tell me what the number for Miss Utility is? It's an easy one. Man, you guys are great. 811, that's right. So you want to call Miss Utility, get those underground utilities marked, because again, nobody knows where they are. We don't even know where the underground utilities are, as demonstrated by this shovel. We had one of our guys, this is actually one of our guys, went to stick a shovel in the ground and he stuck it in. This was the first time he stuck it in the ground, one of our new guys. And got a little, as you can see, he got a little arc. That's the real deal. So, but we're going to use this same shovel to demonstrate what could happen if you get into a power line. And again, this one's real control. We've got a kill switch here. So it could actually be, as you can see from our shovel, that's one time somebody getting into an underground service. You see Ronnie's got earplugs on. Now this time we've changed the voltage around. I don't know if you noticed, but I do want to make sure you guys understand. We've changed the way this thing's fed around, and now it's not primary voltage on there, it's secondary voltage. We're gonna, Ronnie, can you put the meter on there just for our benefit and theirs? We're just gonna test to make sure that we have effectively changed the voltage from primary voltage to secondary voltage, because we don't want to stick the shovel on this thing. All right, so we're good. We're not getting any reading now, so we're good to go there. So we've got secondary voltage, we've got our fuse in here, and this fuse is going to make a loud sound, about like a shotgun. So I'll leave it up to you guys if you want to cover your ears. I recommend that you cover your ears because it is pretty loud. Ready? It will, yeah, you don't have to take off too loud, but it does make a loud boom like a shotgun. Little noise, little smoke. All right, so has anybody heard a loud sound like that, about like a shotgun, and then the lights go out? So that's what, a lot of things can cause that to happen. We're going to demonstrate something else. Sometimes we have a fit with squirrels and snakes and raccoons and that sort of thing. They climb up our poles, and even in our snakes, sometimes will get in our underground transformers or switches and that sort of thing. They cause us some problems. We're going to show you a demonstration here in a minute. What it is, inside that gray barrel, there's a fuse in there. You see the gray barrel that Steve's holding, they're getting ready to install now. There's a fuse inside of there. There's a little conductor in there. We can show you that in a minute, but that's all it is. There's a little fuse in there, and that's our weak link. And when something goes to ground, like we just did with the shovel, it'll blow the fuse. Now, I want to tell you guys, no real snakes are harmed in our demonstration. No real snakes are harmed in our demonstration. That's a rubber snake, so we do have a copper conductor in there just to demonstrate what happens. And it really does happen. We had, not too long ago, within the last month or so, we had about 2,000 customers dropped out just from a snake getting up in a substation. So, I mean, this is a real demonstration of what can happen. And as we come in, if you guys want to cover your ears again, we're going to make that same loud noise. The fuse is going to blow right over there.
All right, here we go.
All right. So, just that old snake climbing up the pole, getting over there and getting from ground potential to especially our high voltage bushings of our transformers. Bang, there you go. Squirrels get up on top of the transformer, sitting on top, the can of that transformer, the gray part of that transformer, ground potential. They get up there and they get on the lead. That causes a problem too. It'll cause that the shot sound like a shotgun, the lights go out, that sort of thing. All right, this time of year, it's just the start of hurricane season. We got a lot of storms coming. You guys just had some storms roll through not too long ago, and a lot of lights go out. Well, one of our hidden hazards for all of us, for our guys, one of the things that makes me most nervous, and you guys, and for the homeowners out there, the public, is after a storm, a lot of customers are going to different places and getting generators. And if they don't hook the generator up correctly, what we recommend is if you haven't had an electrician wired up properly with a disconnect and that sort of thing, it's okay to take a generator and plug an appliance directly into it. But unfortunately, what can happen is homeowners can go in, and if you plug it into an outlet and they don't pull the meter in the meter base, that thing will backfeed just like we're doing here on our demonstration. So if there's a down conductor after a storm, somebody takes a generator, doesn't hook it up properly, plugs it in, it backfeeds just exactly. This whole demonstration is done through backfeed. Now a generator, and we're going to show you, somebody fires up a generator, we've got it plugged in, it's backfeeding the opposite direction, and we're going to backfeed, and we'll show you how that generator fires up and will give us full primary voltage on our line just from that generator. What's it reading, Ronnie? Yep, almost 8,000 volts on our meter there. So that quick, you know, and that's the thing, and the cool thing about our demonstration here, like we just showed, the wire could be down. You know, you could think it's de-energized. If we haven't gone out and grounded it, now if we ground it, it's not going to come back on us. It'll mess our generator up. But what'll happen is you could be out there and this thing, you could be handling it, you could be in the middle of maybe rolling it up. Sometimes we have customers get on our conductors after a storm, move it out of the way. If one of their neighbors fires up a generator that fast, it could change from being de-energized to full primary voltage that fast. Fire the generator up, it's full primary voltage. So never allow anybody, when you guys go out there on a scene, please don't do it yourself. Don't allow any of your partners to get on that conductor, and keep the homeowners and that, you know, the public away from that sort of thing, because that's how fast it can change from being de-energized, even though we haven't grounded it, to somebody firing up a generator, and that's what you've got. So, gentlemen, that's our demonstration.
Tesla Institute, School of Electrical Engineering and Automation.